This video tutorial from exocad will show you how you can quickly design a custom abutment. To start, run the DentalDB application. To set up your first abutment case, select the client. Then, enter the patient's name. Entering the technician is not mandatory. Now, select the teeth you want to design an abutment for. Note that there is no direct abutment restoration type. You must select an anatomic crown, a coping, or an offset coping, and an implant-based superstructure. You can design custom abutments and superstructures together in one single CAD session. Let's choose a reduced coping and select the material for the coping. For implant-based restorations, it is important to set the right option. Select On Custom Abutment. The other implant-based options will be explained in a separate tutorial. The abutment's material can be defined differently from the coping. Using a pre-op scan is possible, but not required. You can use a separate gingiva scan, but it is not necessarily needed and requires an additional step in the scan process. The Design Virtual Gingiva feature will be explained in a separate tutorial. Last but not least, you can choose the material color of the coping. Click OK to finish the restoration definition. To finish the job definition, you can define the adjacent teeth, the antagonist, and the scan mode. Click the Save button to continue, and start the scan or proceed to the design. In this tutorial, we will proceed using one of our demo samples. Click the Load button at the top of the DentalDB. Select the demo sample called Custom Abutment Sample, and click the Load button again. This sample's job definition includes two different restoration types. For Tooth 1-1, an implant-based coping in zirconia was defined. We do not have a pre-op scan, but we have a separate gingiva scan. The selected implant-based option is On Custom Abutment. We have the same definition for Tooth 1-4 and 1-6. For Tooth 1-5, we have a reduced pontic as part of the superstructure. The pontic will automatically connect the copings to a bridge, based on two abutments with unique insertion direction. Click Design to proceed to the design. In the first step, we will detect the implant positions by matching the scan abutments. exocad's implant module ships with an extensive set of implant libraries, which can be used with titanium bases and for designing one-piece abutments or screw-retained bridges. You can search for the type of implant in the full library. Expand the combo box and select an implant from the CAD library. To quickly find the desired library, you can type in the first letters and then scroll to the desired type. Alternatively, you can select the desired library from your favorites list. In this list, you only find libraries you have marked previously as favorites using the corresponding Favorites button. As indicated in the project notes, this demo sample was scanned with the NT Trading K-Series on the posteriors, with an implant diameter of 4.1 millimeters and base as implant family. In the family drop-down list, you can select the library family, such as rotational and anti-rotational units, or between different styles of scan abutments. Clicking the Info option displays information about the selected implant library. It is very important to detect the implant position for the tooth indicated in the wizard. If you detect the implant position for another tooth, it will be positioned on the wrong implant during tooth placement. You can rotate the scan abutment in the wizard by right-clicking it and then dragging it with your mouse. Look at the red point on the scan abutment in the wizard window. Click the same position in the scan data. You can still move the implant by holding the left mouse button and dragging. Next, perform best fit matching to align the scan abutment correctly. If the scan data is not ideal and there are artifacts at the bottom part of the scan abutment, you can cut away the bottom part and exclude it from the matching by moving the slider upwards. This can help improving the results. To define other implant positions, click Next. Repeat the implant detection operations for the tooth indicated in the wizard. One simple click is enough. You can measure the alignment accuracy by clicking Best Fit Matching and pressing Control. Deviations will be color-coded as indicated by the color scale in the wizard. Blue is accurate, and green is still acceptable for custom abutments. You should not see larger areas in yellow, orange, or even red. Click Next to proceed to the next implant. In this demo sample, tooth 1-1 was scanned with a different scan abutment. NT Trading H-Series 4.1 mm base. It is extremely important and crucial for a proper fitting of your abutment's interface with the implant to select the correct scan abutment. Proceed to the next wizard step, which is the Define Emergence Profile step. Since the implant positions and the geometries have been set correctly, we can now define the emergence profile margin line. This process works quite similar to defining the margin line for a preparation. The only difference is that you have to set at least 4 points by clicking positions on the emergence profile margin line to start the automatic detection. You can help the algorithms by adding 1 or more additional points on the emergence profile in case the margin has not been detected correctly. If you have erroneously added a point which is not actually on the margin, switch to Remove Point and click the point to remove. Alternatively, select the Correct Draw tab to adjust the emergence profile margin manually. Move points by clicking and holding the left mouse button. Remove points by left and then right-clicking the point. Add points by left-clicking the green line. You can also draw parts of the margin. Start drawing a second blue line by clicking next to the green line. Set the last point of the new margin also next to the green line and apply with a double click. You can also clear and redraw the entire line. Clearing the entire line requires confirmation. Use these options only in rare special cases, as the automatic detection usually works fine. Finish the drawing with a double click. Also here in the Correct Draw tab, you can delete erroneously added points by left and then right-clicking the point. You can also move the entire line up or down with a specified distance. For example, if you define a value of 0.25 mm and click the down button 4 times, the line will be moved 1 mm downwards. You can undo this operation simply by moving the margin up again. The checkbox Preconditioned Gingiva influences the behavior of the model creator on the emergence profile. This will be demonstrated in a separate tutorial. Click Next to proceed to the next emergence profile margin. Set again 4 points to start the automatic detection. Verify the result. To do this, you can also adjust the light to the view direction. This feature can also help you to find the emergence profile margin in difficult cases. Click the Next button again to proceed to the next emergence profile margin. Set again 4 points to start the automatic detection. If you don't want to design an emergence profile on your abutment, just click the Next button and skip the detection. This might be more interesting for screw-retained crowns and thus will be shown in a separate tutorial. Click the Next button to proceed to the next wizard step. The Copy Tooth step allows you to use copies of existing teeth as library teeth or pre-op models. We will skip this step as it will be explained in a separate tutorial. In the tooth placement step, you can manually optimize the placement of model teeth by moving, rotating, and scaling them. The tooth placement will be explained in detail in a separate tutorial. When placing tooth models, it can be helpful to visualize intersections with the antagonists. The Show Distances function provides some more options if expanded. This will be shown in a separate tutorial. Let us now perform a nice and quick tooth placement. Normally, I set the view from the top and start by positioning the teeth in a line. Then, I switch to the buccal view to adjust the tooth height position and the curve of SPI. Next, I switch to the frontal view to adjust the tooth axis. Do the same with the next tooth. Normally, I hide the antagonist during this initial placement. I think the colored contact intrusions are enough, as I'm not too critical with occlusion now. A nice aesthetic position is more important here. The tooth placement is fine like this. Proceed to the next step, which is the Generate Abutment Bottom step. Here, we design the abutment bottoms, which is the part below the gingiva. Normally, I hide all meshes here and just keep the gingiva with transparency for better design control. Using the sliders, you can adjust the shape. With the upper slider, you can adjust the shape of the abutment bottom's upper part. With the lower slider, you can adjust the shape of the lower part. To set a different shape for the entire abutment bottom, you can use the Shape buttons. Click the right Shape button to create a more convex shape. Click the left Shape button to create a dished shape. Shape changes are applied to all abutments of the whole restoration. If you want to change the shape of only one abutment, use the Freeforming mode by clicking the checkbox Freeform. Left-click where you want to add material. By holding Shift while left-clicking, you can remove material. Left-clicking adds material only locally. To add material everywhere, hold Control while clicking left. Note that this special freeforming mode behaves differently than the regular freeforming. It ensures automatically that there are no bumps and the emergence profile stays smooth. You can visualize intersections with the gingiva by activating the checkbox Visualize. Using this option, you can see how much pressure is on the gingiva or the distance from the gingiva. Blue color indicates that there is space to the gingiva. Red color indicates that there is pressure on the gingiva. You can control the distance to the gingiva using the sliders. This allows you to control the pressure you want to apply on the gingiva precisely. You can use the same sliders to limit the intersection with the gingiva by activating the checkboxes. The upper checkbox is for distance control. Below is for intersection control. Distance and intersection are then determined and limited for all abutments by these values, which you have specified in the fields left from the Limit checkboxes or with the help of the sliders. Please note that this is not a hard limit, but the software tries to enforce it while keeping the shape smooth. As we have now set a very tight limit of 0.1 millimeter for distance and intersections, the software will allow only very small design changes by setting parameters or by using freeforming. If the values are set to 0, the emergence profile is kept close to the gingiva while still being smooth. All other control options do not have any influence anymore. Let's have a look at the emergence profile borders. In a previous step, we have already defined the gingiva borders, which are displayed as a light purple line. To ensure a smooth emergence profile, the abutment borders do not always follow the gingiva border completely. If required, you can change the borders by adjusting the points. Click and hold the left mouse button to drag the points. If you want to create a more complex shape, it is helpful to add additional control points. To add control points, click the margin of the emergence profile while holding Control. To remove a control point, right-click it while holding the left mouse button. By default, the control points are rose-colored, which means that they are attached to the gingiva. Click the toggle disc below the control point to change the point's color to green. A green control point is detached from the gingiva, and you can move it freely. When dragging the arrows, the movement will be restricted to the arrow direction. Now, you can put pressure on the gingiva by creating intersections. By holding Control, you can set all points to free movement mode. I normally detach all points from the gingiva and add points where there is a big gap between the gingiva and the emergence profile. Attach the point, then detach it again. By holding Control, you can move all points simultaneously up and down or inwards and outwards when clicking a point's arrow. If you want to define the emergence profile below the gingiva, or if you want to add some pressure on the gingiva. If you prefer to avoid any pressure, hold Control and attach all points to the gingiva. Let's see this again. Play a little with all the options and finalize the emergence profile design. For aesthetic reasons, I prefer to set the emergence profile round about 1 millimeter below the gingiva border and try to follow the shape of the gingiva border. Sometimes this requires adding some points. In this sample, I will detach all points from the gingiva to create a slight pressure. Now I disable the gingiva adaptation again, as I usually create a convex shape in the upper part and a concave shape in the lower part. Let's have a look at the advanced options. With height, you can define the height at the border between abutment bottom and top. This can be used to avoid sharp edges in this area. Because milling a sharp edge is problematic, there might be material-specific limitations in your software, especially if you want to mill in zirconia. A common value could be 0.2 millimeter. By default, the radius slider is set to 0 to ensure a smooth passage between emergence profile and implant. If you increase this value, the abutment bottom will be bigger than the implant. Checking Allow Below Implant will allow free-forming below the implant surface level. Use this option with caution, as it can cause problems when manufacturing the abutment and is not recommended for hygienic reasons. If you uncheck this feature again, your design will be reset and the emergence profile will be set to a horizontal plane around the implant platform. You can move all margins using the Move All Margins button. With Unstick All, you can detach all control points of all constructions. All control points and toggle disks switch to green. You can achieve the opposite by clicking Restick All. All control points and toggle disks switch to rose color. Proceed to the next step, which is the first freeforming step. We do not show this step in detail, as it is explained in a separate tutorial. Also note that when designing custom abutments only, the anatomic design doesn't have to be very elaborate at this point. Click Next to proceed to the next step, which is the secondary insertion direction step. If there is a bridge on abutments, the first step will be to define a unique secondary insertion axis for this bridge. It is also possible to define individual insertion directions for each abutment. It's obviously better to choose a unique insertion direction, as the abutments must have the same insertion directions for the bridge. If we change the insertion direction for one abutment, it will affect the insertion direction for the other abutments too. To define the insertion direction, click the spheres at the top of the arrows and move them to the desired position while holding the left mouse button. Alternatively, use the classic method of setting the insertion direction from View by clicking Set Current View as Insertion Axis. You must define the insertion direction for each abutment on every tooth. Normally, I try to set the insertion direction arrow in the center of the tooth. And I always ensure that the adjacent teeth do not get in conflict with the coping's insertion. Now, proceed to the next step, which is the abutment design step. Note that with a right mouse click, you can still change the insertion direction in this step. Let's see how to use the control points to design the abutment top. The control points on the abutment can be moved inwards, outwards, up, and down to change the abutment shape. Drag and drop the control point itself for free movement in all directions. Drag and drop one of the arrows to perform movements restricted to the arrow directions. Use Shift and the left mouse button to drag 3 control points in a row, and Control and the left mouse button to drag all control points on a curve. Note that the software avoids undercuts and enforces production-specific design restrictions. Therefore, there is, intentionally, some restriction in movement. And moving one control point can move also another control point above or below. The abutment top is controlled with 3 curves. Move points on the upper curve inwards to create a more conical shape between upper and middle curve. Move points on the upper curve outwards to create a straighter shape. And cause the lower control points to move outwards by respecting your minimum angle. Moving the middle or lower control points inwards will move all points. Moving them outwards will cause only the lower and middle point to move outwards too. Let's see how to use this control point behavior in real situations. To design nice square-shaped abutments on the posteriors, I usually use 8 control points here. So maybe you have to add some points by left-clicking a curve while holding Control. Then I set 1 point on each corner and 1 in the center to create the flat area. This design will protect your coping from rotating on the abutment. Then I move the entire middle curve inwards with Control to define the shoulder width. and the lower curve up or down to define the shoulder slope. Then I finish the square-shaped design of the abutment. Next, I use the upper curves points to design the occlusal area of the abutment. If desired, you can accentuate and support the cusps. And of course, don't forget to verify the distance to the antagonist. Let's repeat the same work steps on the premolar. Set 8 points, 4 on the corners and 4 in the flat areas. Move the entire middle curve with control to define the shoulder width, and the lower curve to design the shoulder slope. Create flat areas on the mesial and distal side and a square-shaped design. Finish with designing the occlusal part of the abutment and verify the occlusal distance. Maybe you want to use your own or a different technique to design abutments. I'm just trying to show you a way how to do it quickly and efficiently. You don't have to do it exactly as I suggest. For anteriors, I recommend using 6 control points instead of 8. Try to design a kind of triangular shape by creating 2 flat sides and define the height of all control points to design the occlusal area, the shoulder distance, and the slope. If you want to design a more conical abutment, just move the control points on the upper curve inwards. You can still switch to the abutment bottom design if really required. The abutment top will be adapted automatically. This looks good so far. Let's switch back to the top design and have a look at the options and features in this dialog. The angle slider in the wizard window enforces a minimum draft angle of the abutment. This doesn't mean that the abutment shape will have the selected angle, but it doesn't allow the abutment to have undercuts below this angle. A good example, choosing 0 degrees does not create a parallel abutment. Higher angles are possible, but you cannot drag points below this defined angle. To enforce the angle applied to the entire abutment, you have to drag all upper points outwards, as we see here. Let's undo all operations and select an angle of 2 degrees, as this is a very common setting. You can also tell the software to enforce a certain space between the anatomy and the abutment using the spacing slider. If the Auto Adapt Occlusal Area checkbox is activated, both the distance and the occlusal shape of the abutment are precisely set off from the chewing surface without moving the control points. This will result in a more reduction-based shape on the anatomical structure. Compared to Auto Adapt Occlusal Area, Apply and Reduce Only will move the control points. This will result in a more geometrical abutment shape. The Apply button will both reduce and extend the shape in order to reach the desired distance values. The button Reduce Only will only shrink the abutment in areas where the distance to the anatomy is below the defined value. Let's undo the previous actions and demonstrate again the difference between apply and reduce only from a different view. The apply button both reduces and extends the shape. The button reduce only shrinks the abutment. Distances to the abutment can be visualized in two different ways. With activating the checkbox Distance to Anatomy on abutment, you can visualize the distance to the anatomy. The visualization is displayed on the abutment. Using the spacing slider, you can now adjust the color scale. With activating the checkbox Distance to Abutment on Anatomy, the distance will be visualized on the anatomy. Also here, you can adjust the color scale using the spacing slider. Let's now have a look at the Advanced Wizard tab. As demonstrated earlier, the slider Height sets the minimum height of the abutment profile border, and the slider Radius controls the rounding at the sharp edge of the border. Expanding milling parameters reveals the following functions. Min thickness sets the minimum thickness of the abutment's axial walls. Diam A sets the diameter of the tool used to mill the abutment, also known as tool compensation. We recommend to add at least 0.2 mm to the smallest tool size. This parameter influences the shoulder profile. Tool C sets the diameter of the tool used to mill the superstructure, crown or coping. This parameter influences the profile at the occlusal edges of the abutments. A small diameter leads to sharp edges. A bigger diameter creates round edges. Please note that these parameters must be set correctly if you want to design and mill the abutment and coping in one single CAD session. Screw dist sets a minimum distance of the abutment to the screw channel. This area will be displayed in red. You cannot set control points nearer to the screw channel than this value. Margin sets the minimum angle of the abutment margin. Verify the abutment design one last time. Then proceed to the last step. In the wizard step, Freeforming, you can freeform the abutments individually, if required. The same options as for crowns and copings are available. These are described in a separate tutorial. You can use the anatomic freeforming to quickly perform bigger adjustments on your design. It's important to know that if you create undercuts, as I do here, these will be blocked out automatically parallel to the insertion axis when proceeding to the next step. In the Free tab, you can perform smaller adjustments or even a simple smoothing on your abutment design. Some users design anti-rotational protection on abutments using the Remove button in the Attachment tab. This will be demonstrated in a separate tutorial. Let's now have a look at how the software blocks out the undercut we have intentionally designed before. When clicking Next, the undercut will be blocked out parallel to the insertion axis. In the last wizard step, you can choose between different options on how to proceed. Choose I'm Done to save the abutments only. or to design abutments and superstructure in one go. The software will proceed with the design of the crowns and copings and starts with the wizard step crown bottoms. This will be shown in a separate tutorial. Let's have a look at the free-form restorations option, as there are two interesting features available. When you click the Free tab in the Wizard Step Freeform Merged Restoration, you can check Freeform Emergence Profiles. This option will allow you to add, remove, or smooth material in the emergence profile area. But you cannot add more material than the emergence profile border allows. This limitation is parallel to the implant direction. Here you can add, remove, and smooth material. You will find another interesting feature in the Adapt tab. Using this feature, you can adapt the emergence profile exactly to the gingiva scan. And as in all other Adapt options, you can specify an accurate distance. A positive value creates a gap. A negative value allows a specified intersection. Finish and save the restoration by clicking Next. Thank you for watching this video.